This word, weight, people use all the time, but even people who do science very often use it loosely. They say weight, but they mean something very specific, the apparent weight. The definition is, apparent weight is a force acting from an object on a surface or support or on a rope suspension. That's what it is. If I take this, well, 1 kilogram weight, we can see the number, the reading. Why is it happening? The force of gravity is not acting on this plate. The force of gravity is acting on this weight, and the weight is acting on this plate. Down, and that's what we read, and that's what we say, call apparent weight, a force acting from an object on a scale, on a table, or on a suspension. We can read this number, we can read it, but again, the force of gravity is not acting on this spring inside on the scale. The force of gravity acting on this weight, the weight is acting on this who. That's what we call apparent weight. The good thing is, due to Newton's third law, if we have an object sitting on a table, there is a force acting from this object on the table. That's what we call apparent weight. But there is a force acting from the table on that object. How do we call it? Normal force. And Newton's third law says they must have the same magnitude and opposite direction. So any question which sounds like find the apparent weight means find the normal force. They have the same magnitude. The apparent weight is not always equal to what we used to call a weight. If I place it like this, 1.5, you can see it, 1.5. But as we just have learned, since we can change normal force, we can change the apparent weight. For example, if I add an extra force, the reading is different. The actual mass and mg didn't change, but if we didn't see this, it would look for us that it's heavier. Now, I can again attach a string, pull it, and we see it decreases. Again, the total mass, same, mg is same, but if we didn't know what was happening, we could think it's getting lighter. There is also a different way to change the apparent weight. Look closely what's going to happen now. So right now it's at rest, and when it's moving, it's not at rest anymore. So velocity changes, that means there has to be acceleration. And we can see the apparent weight changes because of that. What's going to happen if I don't want to drop it, but if I would drop it, what would happen? So we can see apparent weight, it changes again. So let's say you take this with you, walk in an elevator, press the button and start moving. You actually feel like you're getting heavier. That's what apparent weight is.